Hello, hello, hello. Wake up. Class, wake up. Okay, let's have a look at the example. Now we have a utility function q1 squared q2 cubed, and we have a, just like this, we have a budget constraint 20 q1 plus 5 q2 equals 1000. Now, what would be q1 star? We'd like to maximize our utility. What happened to q1 star? So the expenditure on good 1 and good 2 would be 2 to 3, right? The proportion would be 2 to 3. So we make 2/5 of 10,000, 1,000, which would be $400. So this would be $400 divided by 20 and equals 20, right? And what about Q2 star? Q2 star would be 600 over 5, it would be 120. Is that right? And what about the utility? The utility now would be 20 squared 120 cubed. Is that right? Do you think you come across with some problem? No problem here, right? Should be easy, right? So your optimal choice, 20, 120, and replace them into utility function. You have U star. Now, what about if P1 equals a new P1 prime equals 25, and P2 remains 5, and Y remains 1000. What will happen? Q1 prime would be $400 by 25, it will be 16. And what about Q2 prime? It's 1,000 over 5, not 1,000, sorry. It's $600 over 5, 120 still. So you will have U prime by 16 squared and 120 to the power of 3. So which one do you prefer? You want to stay here or you want to be here? You want to stay when P1 is 20, right? Because 20 is cheaper, is lower than 25. And the change from 20, 120 to 16, 120 is on the Marshallian, or on the Hicksian. The result here is on Marshallian or Hicksian. What? Marshallian, right? It's Marshallian, okay? Because from here to here, so the what? The income doesn't change. But if you wanna to find somewhere, what would this point? How to find this point? How can we derive the consumption bundle of this point so that we may have the price of 25 and still remain on the same utility level, right? So now the question becomes a little bit different. Alright, so now P1 prime tilde, P1 tilde equals prime 25 P2 5, but now y must be compensated to somewhere, right? Because you feel poorer. So this compensated income must be higher than 1,000, is that right? So that you may restore to the utility level of this. You need some extra money. So what would be this? We don't know, but we may say, okay, now let's assume it is y prime. Alright, and now say Q1 double prime. I should use with the same thing here. So let's change U double prime, Q double prime, double prime. And we use the notation of prime for the compensated one. So U prime now would be 2/5 of y divided by 25. This is the result. And y prime. We don't know what y prime is. But now, y prime is something compensated. Just keep in mind, okay? And Q2 prime would be 3/5 y prime divided by 5. And the utility U prime equals 2/5 y prime 25 square 3/5 y prime 5 to the power of 3. And if we require U prime equals U star, so it remains on the same utility level, remain on the same indifference curve. Alright, so that we can do this. So we want to make these two equal. What would be y prime? This would be 125 to the power of 5 and 2 to the power of 2, 3 to the power of 3, and y prime to the power of 5. I don't have enough space. Alright. What about y prime? Y prime would be something like how can we do this? We can do this by 20 square, 2 square, so it's 10 square, right? 120 to the power of 3, 3 to the power of 3. So it would be 40 to the power of 3. And 125 and times 125 to the power of 5. Oh, sorry, my fault. It is 25. It is 5. So I made some mistake here. Sorry, I made some mistake here. 5 to the power of 3, so it's 5 to the power of 6, and 5 to the power of 2. So it's 5 to the power of 6. Is that right? So we multiply 5 to the power of 12 here equals y prime to the power of 5. So we may make the results by 1 over 5, right? Take the root of power of 5, the fifth root. If you want to stay here, it's fine. You just make it stay here. But actually we may do something. So you see is 10, if we take 10 out, 10 to the power of 5. 10 to the power of 5. So we have 1 over 5, so we have a 10 here. And 5 to the power of 12. So we can make it like 25. 5 to the power of 2, 5 to the power of 10. So this would be 25. So we have a 25 here. And we have 2 to the power of 6, 5 to the power of 2 over 5. Alright, the number is sort of, kind of not look like beautiful, something ugly, but well, soluble. We may solve this, okay? So once again, our objective is to make the utility remain on the same indifference curve.
My calculator says the y prime is 1,387.58.
Doesn't matter. We don't need that kind of precise number. Okay, it's a concept only. I don't want to make you feel nervous that you need some calculator to do that. I don't need that. Okay? You just keep in mind this is solvable. We can solve this. So I just want to show you how to solve this. So the logic is much more important than that. Then you have a precise. I would not require you to find some precise number, but you need to remember why we make this. Y prime is something correspond to this budget line. Okay? Because this Y corresponds to $1,000, but this Y prime must be higher than 1,000. But we don't know what it is. But this income can make us stay here. And this provides us the same level of utility. Alright? So the relative price now becomes 25.5 as compared with 25. So this is 25 and 25.5. Okay? The relative price here. And so let's assume this budget line corresponds to Y prime so that we may have this result and the utility function or the utility level, we want to make them equal to each other. Of course, I may give you something simpler as I erase the power 2 and 3. But the reason why now I give you something looks like complicated is because I just want to show you that this is solvable. We can we can find the solution here, but we don't need the precise number. Okay? If you may put something as here, even you do not find the final answer, it's fine. You just keep in mind, given this condition, given this exogenous variables, we may have endogenous variable solutions look like this. Okay? Now we may do something simpler. If we change the condition of the problem. So now let's change the utility function into Q1 and Q2. Q1 multiply Q2. Alright? And still, the very first case is 20 Q1 plus 5 Q2 equals 1000. And the solution would be Q1 star equals what? Because now the expenditure would be 1 to 1, right? So we divide $1,000 into $500, $500, 500 equally, because 1 and 1, right? So it would be $500 over 20, 25, and Q2 star would be $500 over 5 would be 100, and the U star would be 25 to the power of 1, 100 to the power of 1. And now, if we are facing this condition, P1 prime equals 25, and P2 remains 5, and now we don't know the compensated income. We call it Y prime. What would happen? Q1 prime would be Y prime divided by 2, and divided by the price, 25. And Q2 prime would be 1/2 of Y prime divided by price, 5. And the U prime would be to the power of 1 and to the power of 1. So you see, it's simpler than this case, right? But in this case, we like to find a solution so that the utility level will be the same. So it's easier to find Y prime, is that right? So in this case, what would Y prime be? It would be 50, 10, 500, 500, 500, and 25. So 2500 and 500, and take the square root, because we have 2 Y prime. So the square root of this would be, is 5, is 10, 500 and square root of 5. 500 and square root of 5. And now you will see, do you think this number is higher than 2 or less than 2? The square root of 5, it says 2, right? It's higher than 2. If it is 2, then it will be 1000, just like here. Just like here. But now you see, this number is higher than 2. So Y prime is actually higher than 1000, right? That is what I called compensated. Because now the price P1 rises. with a higher price, our real income is cut. But if we want to stay in the same stay on the same level of utility, stay on the same indifference curve, we need to compensate the income. So how much we compensate this consumer so that he or she may remain on the same indifference curve? How much we need to compensate her?
Y prime minus.
Yes, y prime minus 1000, right? So it would be 500 times the square root of 5 minus 2, right? This is the number, or this is the amount we need to compensate this consumer so that under this condition, under this relative prices, he or she may remain the same utility level. Okay? So you just compare this case and this case, and the difference comes from the powers of Q1 and the powers of Q2 in the utility function. So it's 2, 3 is 1, 1. Of course, this looks simpler, right? And this a little bit complicated. But you will see the same logic. You will see the same logic. Is that clear? All right. Any question here? Alright, deriving the compensated or Hickshan demand curve is straightforward with the expenditure function. So E is the smallest expenditure. Okay. Let me show you this. Now before that, I'd like to check whether all of you can understand what I'm talking about. Given the initial condition, you may have optimal choices, or you may have optimal choice of Q1 and Q2 star. And finally, you have this utility level because you just replace the optimal solution back into the utility function, right? So we may have this. Now, with a new price and something we assume this is the income after compensation, so that we may have the same level, we wanted to make them the same, to make these two utility levels the same. Okay? I have already erased the diagram, but you may check from your slide. Remain the same, okay? With another price, with the new prices, we want to keep on the same utility level so that we would like to find this solution, okay? So this is the first way. We may have several ways to solve this. This is the first way, to assume an y prime. With this y prime, and we have this utility level, and make them the same, so that we may solve y prime as 500 times the square root of 5. Okay? And with this solution, actually, you may have what? You may have the exact solution of Q1 prime and Q2 prime. So now since you solve this, you may check them back into the formula so that y prime divided by 2 and 25 is 50. So it's 10. Now this would be 10 times square root of 5. And what would be this? It would be 50 square root of 5. Is that clear? All right? Now, let me show you something different. I just use way number 1. Now I'll give you way number 2, the second way to solve this problem. So we may minimize our expenditure, which is 25, because now the price changes. P1 rises, so it becomes 25 Q1 plus 5 Q2. We'd like to minimize the expenditure. And our budget constraint would be Q1, Q2, this is the utility function, right? This is the utility function, equals 2,500. Do you remember we usually use U bar to denote this, right? So now 2,500 is actually the level of this indifference curve is 2,500. How can we do this? Lagrange, right? Lagrange 25 Q1 plus 5 Q2 plus lambda. And now it's 2,500 minus Q1, Q2. So partial differentiation with lambda, we have 2,500 minus Q1, Q2, set 0. Lagrange 1 would be 25 minus lambda, Q2. And Lagrange 2 equals 5 minus lambda Q1. Alright, so Q2 over Q1 equals 25 over 5 because lambda can be cancelled, right? So Q2 equals 5Q1. Okay? And let's take this back into here. So 2,500 equals Q1 with 5Q1. And so Q1 prime equals the square root of 500. Is that right? Actually, it will be 10 square root of 5. 10 square root of 5. Right? What about Q2 prime? It would be 5 times of Q1. So it would be 50 the square root of 5. This is the second way. Alright? Given the requirements of this indifference curve with the price, the minimum minimum expenditure would be this one. Okay, this would be the minimum expenditure. And since our solution looks like this, So the minimum E would be 25 10 square root of 5 plus 5 50 square root of 5. So it would be 500 square root of 5. And this expenditure is exactly y prime.